thank you all for joining. Good morning, my name is Rachel Nicely, and welcome to the Carbon Leadership Forum Washington, DC Hub February webinar event. Today, we will be hearing a case study on 80 M Street, mass timber structure in Washington, DC. So we'll hear from Lauren Wingo, Senior Engineer with Arup, Sean Fox, Senior Project Manager with Davis Construction, and Jason Wright, Associate Principal with Hickok Cole. So excuse me. The Carbon Leadership Forum aims to transform the building sector by reducing embodied carbon in building materials. The forum was established as a platform for resources, research, opportunity for networking, and includes many initiatives to accelerate market transformation. So become more involved through the channels on the screen. Our website includes event details and recordings of past events, including this one in a few weeks. Reach out via our email or through the forum. But the best is probably through LinkedIn, where you can keep up with events, and please use it as a platform to start a conversation around embodied carbon for us all. Just a quick announcement. So thank you all for those who participated in the workshop at the end of the last year in the survey. So we heard from you, and the areas that we would like to focus our next year in our events and networking around are education and awareness, EPD availability, and policy. So we appreciate all that feedback. We'll do our best to try and develop kind of the programming around those areas. Also, thank you for those who indicated that you're interested in volunteering or involvement in workshops. We'll be reaching out to you within the next week. And please feel free, if you weren't able to fill out the survey or join the workshop, but you're still interested in involvement, please feel free to drop your contact information in the chat function, and we'll be happy to contact you and involve you in our next planning session. So just a quick update is March 4th, we're planning to have our coffee break. So watch out for the event invite and please sign up. We'll be hopefully discussing this event that we're having right now, as well as any other networking opportunities. So looking forward to that. And with that, I will turn it over to Jason Wright to start the show.
All right, thank you, Kirsten and Rachel, for setting this up. Can you give me presenter rights so I can share my screen?
All right, I think you should be able to share now.
Yeah. Okay. Can you see my screen okay?
Yes.
Yep, looks great.
All right. Well, thank you all for joining us this morning to talk about 80 M Street. Sean, Laura, and I have been on kind of the 80 M Street road show for the past 18 months. So we're excited to make another stop here and talk to you all at the Carbon Leadership Forum about this project. I think we're all really proud of it, and it's been a kind of truly team partnership to get it to where it is to date. So the case study for 80 M. All right. So a little bit about Hickok Cole. This is our mission statement. We're a forward-focused design practice. We connect bold ideas, diverse expertise, partners with vision to do work that matters. And I think the partners with vision is really part of the key initiative on this project and what has kind of got us to deliver such a great project. Part of our internal mission at Hickok Cole is to do research, and we have an internal microgrant program, which we call iLab, where staff can submit applications for projects they would like to request hours to work on to develop an initiative that goes forward into the type of work we do. And these are some examples of some iLab projects that we've done internally over the past few years. that have actually developed into real projects, mass timber being one, which we'll talk about today. Net zero, we were able to deliver the first net zero renovation project in Washington, DC at AGU. This micro hydro skin that we prototyped and developed with a fabricator in Pennsylvania, modular housing. So these are all kind of internal research programs that kind of bore the new ideas and how we got to mass timber. So in 2015, a group of our coworkers submitted a micro grant to explore mass timber, and their goal in 2015 was to understand how timber worked, its sustainability aspects, how to detail with it, its limitations. And that really then spun off into a competition that we did in 2016, 2017 called Timber Towers, which was the Sky High skyscraper competition, which we partnered with Arup on. And this was, I think, a great learning experience for all of us. We learned, kind of thought outside the box and even pushed kind of the limits of what could be done with timber, and put together a concept that was basically the 2 million square feet on a downtown site in Philadelphia that was a mixed use of residential, high-rise office and institutional school use. And it was a great partnership with Arup, and out of that, the project, the competition received an honorable mention, and I think we kind of felt a kind of symbiotic relationship, and we were working well with the Arup team, and we continued to kind of talk about and discuss mass timber opportunities and bring it to clients in the marketplace. Around that time, in the late fall of 2017, Columbia Property Trust, who is the owner for ADM Street, actually approached Davis with a site that they had, and they were looking to add density. And Davis, through our relationship working with Davis, brought us in to start talking about kind of concepts for ADM Street. So talk a little bit about the site for ADM Street. Most of you, I think, are in the DC market, but just in case some of the folks here are not, the ADM Street project is located in the Navy Yard district, which is a submarket that has really kind of grown over the past 20 years with the addition of the baseball stadium in 2008. Obviously, the Navy Yard is here, and the Michael Graves Department of Transportation building sits right here. The site is less than a half mile south of the Capitol, close proximity to the mall, 695, the Green Line Metro tunnel runs through here, and also at the confluence of the rivers. So the building it's not a K Street downtown building, but it's in a very much growing neighborhood, but it is actually one of the first high-rise building built in the Navy Yard submarket. And it was completed in 1999, 2000, so 20 years ago. So a little bit about the building itself. So the building is a 7-story building, only built 90 feet tall. Again, first high rise, so it was really the first office building kind of coming into this submarket, and was built for really defense contractor tenants who were working at the Navy Yard. So we jokingly talk about this project as the initial building is a mullet, the kind of a business in the front and then party in the back with just a brick punch windows. And so one of our challenges was how to expand this building well occupied. So that was one of the key factors that we had to keep in mind, was that the bottom 6 stories of this building were always intended to be occupied. And so Columbia kind of tasked us with a mission of, well, how do we add density to the building? It's zoned for 130 feet. So those of you who know DC, we kind of have varying building heights based on street width, but because of the width of First Street here, we could go an additional 40 feet above the roof line of where the existing building was. So our challenge was how do we add density to the building while not adversely impacting the current tenants, and kind of transform the asset. Our first kind of step in the process was to kind of look at the massing of the building and the density. So this is the existing structure, 7 stories and a penthouse. And we looked at various schemes of taking off the penthouse and the roof, because the existing roof was designed for roof loading and not for office loading. We looked at adding 2 stories and a penthouse. We looked at adding 3 stories in a penthouse, we looked at adding 2 stories, and then a setback at 2.5 stories, and then a mechanical penthouse above, or 3 stories and an occupied penthouse. The 3 stories with occupied penthouse would have given them the most density on the site, but adding 3 stories in 40 feet would have required us to use probably a concrete structure, which would have added more weight to the columns and required foundation reinforcing. And that kind of was a non-starter for an occupied building. We worked with Arup through the early design process to do some concrete sampling, and it was pretty evident that the existing structure couldn't take the weight of concrete without significant reinforcing. The other downside to delivering concrete in the market was we would have been delivering kind of, call it market rate space. So we're in a different submarket than the kind of K Street corridor, and to deliver this kind of space in that market really would have been a challenge to lease. And so we started looking at this option here, which was saying, hey, let's build less density, but let's make it unique and special. So we kind of landed on this 2 stories plus a penthouse scheme to try and differentiate ourselves in the marketplace. So when we started looking at this project, we kind of had this notion with Columbia and Arup. We said, hey, if we're going to go 16 feet floor to floor plus a penthouse, why don't we do it in mass timber? And I think Columbia was kind of like, excuse me. And we said, we kind of presented these case studies that we've been talking about and said, we could do it in steel, we could do it in timber, but we're looking, we're really interested in doing this in mass timber. It's a unique new building material. It would create a diverse product for the marketplace. We talked about the sustainability of it, the biophilic design, and how it really create a space that would set us apart from other buildings in the marketplace. And in addition, this is kind of a conceptual section through the building. You can see that we have 16 feet floor to floor on the upper levels. The amount of light penetrating deeper into the space because of the higher floor to floors was much more significant than the lower floors. And so, all of these things are starting to show a space that would be unique and lend itself to be unlike any other space in the market. And we thought that there was a real value to it. So working with Arup, we started putting together kind of conceptual design packages and pricing it. We were always, as we started designing this vertical expansion, we're kind of benchmarking it against steel. And I think Sean will talk about this a little bit later, but it was always kind of looking at steel and timber to see, how this would lay out as a vertical expansion. And the first kind of big hurdle after cost was, well, can we get it approved? Nobody's done a high-rise mass timber office building, not at 130 feet, in our case, 150 feet to the penthouse. And so the question was, well, how do we get it approved? So this was back in late 2018, and we're both Arup and Hickok Cole, through our mass timber research, have been following the developments of the code with relation to mass timber, and knowing the 2021 building code was coming. It was introducing 3 new construction types for mass timber: 4C, 4B, and 4A. 4C would allow an office building to go 9 stories at 85 feet, and 4B would allow you to go 12 stories at 180 feet. But there's some distinct differences. Type 4C is, for those of you familiar with the construction types, is essentially your type 4 heavy timber with but using mass timber, so it allowed you to leave it all exposed. But when you get to type 4B, you are required to have a 2-hour rated frame, but you have to protect roughly 80% of the timber with non-combustible materials. And a lot of that was born out of the testing that had been done to date, and the materials in the early testing that was done with mass timber. And so this was kind of a conservative approach that we felt to designing with mass timber. And in addition, there were some other code requirements for redundant fire pump and other things that were triggered at 4B. And, in our discussions with Columbia, we said, well, we really want to push the biophilic feel of this timber, express it, and from a marketability standpoint, if we can't expose it, it's not really worth doing in the marketplace. So we kind of looked at ADM and said, well, we're not 4C because we're at 130 feet, 150 feet to the penthouse. And we're not 4B because we're not 12 stories. We're really kind of a 3-story building on top of a 7-story building. So we put together a strategy and a proposal, and we went to meet with DCRA in March of 2019. And we kind of laid this all out. We said, here's what's coming in the model code. Here's what we want to do. This is why we think it's a safe product. It's an equivalent. You know, I think at first they kind of looked at us like, okay, well, let's talk about this a little bit more. And I sit on a group in the district that's involved in adopting the new code cycles, the new building codes. And the group on the DCRA side was very interested in mass timber. So this wasn't a foreign idea to them, but it was just coming to them right off the bat and saying, hey, there's all these new things that are coming in the code, in the 2021 code, but hey, DC at the time was still in the 2012 code. It's a big leap. They were willing to embrace it, but we had to kind of talk through strategies with them. And then to come to them with a project that already was kind of not fitting into the buckets of the forthcoming code was a bit of a, not a challenge, but we had to kind of work with them to talk through the process. So this is kind of where we ended up with that. Is we got relief to do a type 4C building so we could leave the timber exposed, limited to 3 stories. And some of the things that we think were trade-offs that we were able to kind of proffer were the ability to have fire department access on all 4 sides of the building. We incorporated some of the requirements of type 4B construction into the design of our building. And then we also additionally, this is showing the 4-sided fire department access. We also constructed the core of the building out of composite steel construction. So our means of egress components, the stairs, the elevators, were all in this kind of composite steel construction. And we really did this, and Lauren will touch on this in a little bit later, is for the lateral bracing, but it allowed us to kind of also take advantage of the life safety benefits and the familiarity with the code officials to say, hey, the core of the building is in type of construction that you typically would see at a 130-foot building, but allow us to do the kind of occupied spaces on the expansion floors as timber. So this kind of section illustrates the existing concrete building. The green portion would be the timber, and then the center core in composite steel construction. So that we were able to get that approval actually fairly quickly through DCRA in April of 2019. And basically our client said, okay, you know, that's step one. If you can get approval, you know, we will seriously consider this. So we were able to bring this real project, get approval. Now the next thing was we needed to find a tenant. And actually rather quickly in the marketplace, Columbia and our broker JLL were able to secure a 60,000 square foot tenant, which was to take the 8th floor and half of the 9th floor. And basically at that point, we were off to the races because the existing 7th floor was vacating January 1, 2020. And so that was kind of our, actually 2019, excuse me. And so that was our, you know, let's go standpoint. So they really wanted to get going on it. And having locked in a tenant, we were ready to go. And so basically we had about 8 months to put together a CD package and get out on the street. And working with Arup, we were able to kind of put together an early release package to bid the timber and also the facade, the curtain wall package, because the structure of the timber goes up so fast, we had to be able to kind of enclose it. And Sean will talk about schedule in a little bit. So one of the other things that we had to do, because as we talked earlier, the existing roof couldn't take office loading. We looked at different strategies with Arup and Davis and through pricing to figure out how we could support the new timber structure on the existing roof without having to do significant reinforcing. And because we had additional height on the site, we were able to build a kind of interstitial steel layer, which gave us a clean spring point to build our timber structure above. Because of the tight tolerances with timber, it gave us a little bit of time and a better working platform to start the timber construction. A little bit about the building below. It the building below is a 30 by 30 grid. And so structurally, we had to honor that grid coming up through the building. And so this is a conceptual layout of the 8th floor. As I said before, the building before is 40,000 square feet. And our design challenge was trying to find a way to kind of put a fancy hat on the mullet and not make it look odd. And so one of the things we did was to pull back the south facade to create this 8th floor terrace. And even in, I guess, the pre-COVID days, tenants were always looking for outdoor space. And so doing this gave us a marketable 8th floor terrace. And then we were also able to add 3 terraces up at the penthouse level. But you can see this building has really deep floor plates, 60 feet to the core, 30 by 30 grid. And that 30 by 30 grid is not optimal for timber framing, right? So this led us to a system which consisted of girders and beam framing. But because we had a 16 feet floor to floor, we were able to kind of work with these deeper member sizes. And I think Lauren will talk a little bit more about the structure in a minute. So these were some kind of early marketing images that we were able to put together that kind of showed what the space would look like at this height and scale. And I think these really resonated in the marketplace. We had a lot of traction because it was unlike any other product in the marketplace, and people really gravitated to the warmth of the timber and the kind of openness and the daylight. So it received a lot of traction in the marketplace, even during design. And we were fortunate enough to be able to kind of lock in a tenant early to really get the project kicked off. So in our early design assists, we partnered up with Katerra. And one of the challenges that we had for this project being over 130 feet and being a true high rise is we had to develop 2-hour rated connections for the structure. The CLT and glulam had already been tested to 2 hours, but at the time, there was only one connection for beams to beams and beams to columns in the market that was 2-hour rated. And that was developed for a project out in Portland called Frameworks. And the testing was funded by the Forest Service. And that project actually never got built. And so one of our challenges was to kind of work with Katerra to actually develop new 2-hour rated connections for the beam to beam and beam to column connections. And so between Katerra, Davis, Hickok Cole, and Arup, we all worked together to kind of design these connections in a way that the steel that supports them was fully concealed. And these tests were done, both this test for the beam to beam and beam to column were then taken down to a lab in Texas and done a 2-hour ASTM E119 2-hour fire rating test was done. And so this is kind of an exploded axon, so you can kind of see how everything goes together between the glulam columns. There's a steel support post that helps transfer the load, the girders that frame into the side of it, and then the secondary beams, which then have these steel connectors that are supported on the girders, and the CLT panel that rests on top. So this is kind of exploded axon, but you get a better sense as to what how it all goes together, because in the finished product, you don't actually see all these steel connections, but the fireproofing of these steel connections is critical. You could do exposed steel connections and put intumescent paint on them, but I think you lose some of the beauty of the timber seeing these exposed connections. So you can see here, these were some of the test photos from Southwest Research. And so this is the column with its support tube, and then the glulam in the back. And then this is the assembly and the furnace getting set up for the 2-hour fire test. And then this is the result of the 2-hour fire test. And so what was critical for us was to make sure that this test is all done under load to simulate the actual conditions. And for us, it's critical to obviously make sure that the connection doesn't fail and can retain the load, but also that the char on the members doesn't exceed their required structural depth. So I think most of you are familiar with mass timber, but mass timber gets its internal fire rating basically by adding more mass and char to it. So the members are oversized to allow the outer layers to char, but retain the kind of structural depth and core on the inside. And so you can see what was the reduced member depth and width on the beam post fire testing here. Similarly on the column here, and then you can see the connection here between the girder and the secondary beam post tests. But all this, was done during the design assist phase and the shop drawing phase, because we had some modifications to the elevators we had to do, which I think Sean will talk about schedule a little bit, gave us some time to explore and develop these new connections for this really unique project that required these 2-hour fire test ratings. So here you can see the finished product. You've got the secondary beams here, girders in the post, and what's really elegant about this, about the design of those connections, is you don't see anything, and it's really clean. It allows you to really celebrate the timber and not see all these steel brackets all over the place. Again, another kind of rendering of the conceptual space on 8, opening up to that terrace. One of the other kind of challenges to bringing timber to the DC market was getting other trades up to speed and not fearing timber. And we could budget the timber all day long, but if all the other subs were bidding it and were adding a premium to be working with it because they weren't familiar with it, that was going to be problematic for the project as a whole going forward. But we were fortunate enough to have good partners, and TSI was the curtain wall installer, and they brought a partner to the table, Erie out of Toronto, who did a unitized curtain wall. And part of the teamwork was working with Arup and Katera to figure out how do you actually anchor a curtain wall system to a CLT slab system. And we kind of went back and forth, and working all together with the different engineers, we were actually able to take a standard curtain wall anchor and basically use timber fasteners to anchor it down to the deck. But it took a lot of kind of coordination back and forth with Katera's engineering, kind of providing Erie's engineering team with information on timber fasteners, and Arup and Katera together analyzing the existing slab and the lateral bracing system to make sure that all the loads were kind of being transferred appropriately. But in the long run, it wasn't a revolutionary solution, but it just took teamwork and everybody getting together and kind of talking and sharing their knowledge. So you can kind of see here, once the concrete was poured, it looked like a normal DC office building curtain wall anchor that was ready to receive a unitized curtain wall. So it was definitely a team effort, but working as a team and sharing knowledge, we were able to kind of overcome, I wouldn't say challenges, but just new dimensions to this product in the market that the team wasn't aware of. So on the upper left here, you can see the original building. And this was just about a year ago, probably 11 months ago, as the timber was starting to be erected. And then these are some photos from actually earlier this week. We're getting really close to substantial completion, but the project has really developed better than we could ever have hoped, and leasing has gone very well. We just signed a big tenant lease for the 10th floor, and so there's only a few spots left, and we always say kind of the best building is a lease building. So we've been excited about that, and we're continuing to kind of push forward. There's just a few more shots of the interior space, but you can see, the daylight we were talking about and how deep it penetrates into the space, and how clean the aesthetic is, and the floor to floor heights. It's definitely unlike any other space in DC. When we take clients through, everyone immediately goes and starts, touching the timber and embracing it. I think the warmth of the timber, it really resonates. One of the early on in design, our client was out in Jackson Hole at the Jackson Hole Airport, and he sent me a picture. And the Jackson Hole Airport, if you haven't been there, is all done out of mass timber. And he said, "Who wouldn't want to work in an office like this?" And I said, "Exactly. This is why we're doing this." And that was 3 years ago. And now we're kind of getting close to delivering it, and I think it's kind of met all of our expectations. We've learned a lot along the way, but it's been a great partnership with everybody, and we're looking forward to kind of doing the next one. So With that, I will hand it off to Lauren to talk about some of the structural challenges.
So hello, everybody. I'm Lauren Wingo. I'm the structural engineer on the project, as well as the project manager from Arup. So I'm going to talk a little bit with this group also about the embodied carbon aspect and the life cycle assessment we did for the structural portion, as well as some of the engineering challenges that Jason was alluding to. So a little bit of a background on mass timber in the district and our involvement, Arup's involvement with mass timber. This is a project that we completed back in 2016. This is the Washington Latin Public Charter School Gymnasium. And at the time, you know, CLT wasn't even integrated into the DC code as an acceptable material. So we worked really closely with DCRA on getting acceptance for it just as a material to start, and kind of helped with that education that helped foster a lot of the success that we had with the ADM Street project. And then we've similarly done this with a lot of other jurisdictions here locally. We have a project out in Ruston right now with Fairfax County and working through with the code authorities on that one. So I think it's just important to note, you know, kind of how much effort has been put in by us, Hickok Cole, a bunch of other entities over the years in getting mass timber in the district. And then Jason mentioned that we've been researching mass timber with Hickok Cole for many years, and he highlighted some of the work we had done there. Additionally, you know, we continue with our collaboration to this day. And last year, we got one of the DOE grants, which are open right now for application, and we used it to fund a study doing a life cycle assessment, looking at an alternate mass timber option to another commercial office building. But then, of course, ADM Street is the project that we've been working with Hickok Cole that we actually got to realize our vision over the past couple of years of having a mass timber project of this scale in the district. So kind of segueing over into the embodied carbon aspect to start, and really making a case for the benefits of this building from that standpoint. I really like this graph. If you haven't seen it before, it highlights the embodied carbon reduction potential of really kind of like high level strategies. And of course, the best strategy is to build nothing, because you 100% avoid any embodied carbon emissions. But going from there, what you want to do is utilize existing buildings to the extent possible and build less. And then if you are going to build new, build clever using low carbon materials. I bring that up because the biggest embodied carbon strategy on this building is actually utilizing the existing building. And honestly, some of the engineering and constructability challenges came more so from the existing building rather than the overbuild. But of course, you know, when we were doing the overbuild, we wanted to use a low carbon material, and mass timber, of course, is a great option for that. So just to put it into context, and also I think it speaks to how great of a building type this is for DC being a dense urban environment. If we can utilize our existing buildings to the extent possible, add density through additions that use low carbon materials, that's really the best solution. So in terms of what that means for embodied carbon, we did a life cycle assessment just of the structure alone, and comparing the overbuild to internal benchmarks we have of office buildings in the area, we saw a 40% embodied carbon or global warming potential reduction from using mass timber. But as I mentioned, you know, this is an existing building that we're adding to. So if you do it on the basis of the total building square footage and acknowledge that existing building reuse, it's actually an 85% embodied carbon reduction. So you see most of the savings are from utilizing that existing building. And I think speaking to what Jason was saying, you know, this was otherwise seen as maybe a less desirable building asset before we did the addition. So we're really reinvigorating it and making that story of using the existing building and avoiding those embodied carbon emissions that could potentially happen if you had demolished a building. In terms of kind of available benchmarks or comparisons to make for embodied carbon when you're doing these types of studies, I really like the score system that's from iStruct-D in the UK. And I like it because it's not really a set benchmark. It kind of just helps you understand the range of where your building is performing, and is it on the lower side of the spectrum or the higher side. You know, like high-rise ground-up construction, you're going to have a really carbon-intensive building. But again, when we look at ADM Street and on the basis of the existing building, we're getting an A++ rating based off of this. And it's really acknowledging the fact that we're using the existing building and then using low carbon mass timber. These are the results of the LCA study that we did. And for the structural engineers on the call, you know, part of our internal desire to do LCA on all of our projects now is our reporting to the SE 2050 commitment program. And then if you look at the results, a couple of things to highlight, building upon the previous presentation for the CLF DC Hub on mass timber. There is this important concept of the carbon cycle of wood. And so when timber is ultimately disposed of, the carbon gets released back into the atmosphere. So you see that the timber actually has a fairly large contribution to the overall embodied carbon. And then if you look at the breakdown by life cycle stages, there's a large portion attributed to end of life, which if you were looking at a concrete or steel building, this would be a lower percentage of the overall results. And then here you can see our results. This is reporting out for A through C. And again, this is just for the structure only. So touching upon some methodology and the standard practice that we use internally at Arup, but also that we're seeing as standard practice within the industry. We exclude biogenic carbon from our assessments. And then if we are to report it, we want to report it separately. We report A through C rather than A through D, so that you're not claiming those benefits beyond the system boundary and really doing a cradle to grave assessment. And then specific to timber, I think it's really important to point out that depending on what tool you're using, there's a lot of variability in results. We typically use Athena and Tally, and between these two, they have completely different end of life assumptions. Tally ends up having higher assumed impacts because they're assuming more incineration and more decomposes rather than gets stored. That's just something to be aware of as you're doing these studies, that if you run it in two different softwares, you're going to get different results. Okay, so switching gears over to the engineering challenges, I think a lot of what Jason was pointing out and what I'll speak to now is that while for mass timber, I think we've overcome a lot of the design challenges, and that shouldn't ever hold up a project. There is a lot that you just have to be aware of because there's not industry standard solutions yet. And we sort of take for granted when we're building out of more traditional structural materials that there's just a lot of industry standard detailing and things like that that we rely on without even thinking about it. So Arup, we're a multidisciplinary firm, if you're not familiar, and beyond the traditional building services, SM&P, we also have fire code consulting, acoustic consulting, specialists in vibration, and then sustainability consultants. And because there's not industry standard solutions yet for mass timber, broadly speaking, you really have to take an integrative approach to solving some of these solutions. And we were able to leverage that a lot on ADM Street and combining all of our just different disciplines to create the appropriate detailing strategies, for example. Okay, so this was touched upon of just our general structural system. Our primary gravity system is the CLT on glulam beams and columns. And originally what we wanted to do was reserve the timber for the tenant areas where it could be exposed. And then in the back of house spaces, for a code compliancy standpoint, we needed to use a steel lateral system. So we use steel brace frames. You couldn't do CLT shear walls based on the code provisions, but also it's not really as stiff. So I think generally speaking, like you see on a ton of mass timber projects, they either have a steel lateral system or concrete shear walls. So that's what we did here. And then since we did reserve the mass timber to the tenant areas, this whole back of house space became steel. It did serve us well for what Jason mentioned of like the egress stairs are all out of steel in a standard construction. So you're not even waiting to egress down 3 stories to get to a more conventional material. You just immediately egress on each floor into a steel framed area. And then also what we realized the benefit of doing this out of steel is that, you know, we had our mechanical rooms and things like that in the back, which had a lot of penetrations and serving up from an existing building. Sometimes we didn't know exactly where things could get routed. And if we had done this out of CLT, you want to have everything precisely coordinated for the CNCs to, you know, put in those openings. And that coordination was just more difficult with an existing building to happen early on. And the steel framing helped to accommodate more of those penetrations and openings. This is a framing system. Mentioned previously, we have a 30 by 30 grid, which is pretty large for mass timber. Usually you see at least one direction being a little tighter at around 20 foot, I would say. And as a result, we have some pretty deep beams, but because we have generous floor to floor, we were able to accommodate it. Footfall or floor vibration is one area that there's not a ton of industry guidance on, or at least there wasn't at the time when we were in design. So fortunately, we have an advanced technology and research team, and out of the UK, they had done some research into timber vibration. And for those of you who don't know, because mass timber is so lightweight, it tends to get bouncier than other types of structural systems. So it is something that you need to be aware of. So thankfully, we had that internal guidance when we were in design, and we really wanted to make sure that the occupant experience in this building was going to be the same as that of a concrete or steel building, because if we're introducing this new product to the commercial office marketplace in DC, we don't want someone to come into the building and have a negative perception of mass timber because it's bouncier or louder or something like that. So it's really important for us to have floors that weren't bouncy. Since we completed design, Woodworks has released a mass timber floor vibration guide. This is a sign that like industry is progressing forward, and organizations like Woodworks are doing a great job of filling in the gaps. But like I said, at the time when we were designing it, we didn't have this. And then earlier this month, we went on site and we did some in-place vibration testing, and it's performing really well. And so that's helping validate our results and also help inform the industry as a whole of how to approach vibration in mass timber structures. Acoustics, our structural buildup is integrated with our acoustic solution. So we're using this Acoustimat product that Davis helped to source. And then on top of the acoustic mat, we poured concrete that serves as our structural diaphragm. This was kind of one of those other code aspects where there's a more clear pathway to use concrete as our structural diaphragm as opposed to CLT. So this buildup that we used on ADM, I would say it's like becoming more of an industry standard because you get to expose the underside of the CLT. But again, this is one of those things where like some of the suppliers have tested solutions, but for the most part, people are kind of like reinventing the wheel for each project. And then connections, Jason touched on this. We did a lot of effort early on in making sure that we could achieve 2-hour rating on these concealed connections because we knew it would be the most challenging aspect from a fire point of view. So we developed these early kind of concepts and then handed it over to Katerra as the timber subcontractor. And because we had their early engagement through a design assist framework starting at DD, that was super beneficial and honestly the only way the project would have been as successful as it was, so that they could further develop the design and then get them tested. The other thing about these connections, so similar to that like vibration guidance document not existing while we were in design, there wasn't and is still not currently within the NDS code, which is what we use for structural timber design, any discussion of fire protection of connections or like how to design that. They do speak to how to design the members themselves, but not the connections. So there's, you know, just no guidance out there. And thankfully we do have internal experts that are fire structural proficient and timber engineering, and we could kind of use analysis to understand like it ends up charring more at the connections because you have a lot more material there, and we could predict how much char was going to be there and make sure that the concepts we were giving over to Katerra that we were confident would work. Another connection that we had to work with Katerra on was these integrity straps around the columns, and this is detailing to help with preventing progressive collapse. This is another thing that we take for granted for concrete and steel construction, that like the detailing inherently that we use for concrete and steel allows for this. But in timber, again, no industry standard solution. So we worked with Katerra on developing something to use for this project. So yeah, a lot of challenges along the way, but it was fun and didn't hold up any of our progress because we approached it well. You know, we had great partners, and then we really did our due diligence in engaging with the local code authorities, making sure that the procurement was done right, and that, you know, on the contractor side that we had the right project partners. And as Jason mentioned, it's been really successful. It did go better than I think all of us thought it could. I think I got maybe like 2 RFIs while the mass timber was going up. So if that's any indication of how successful it went up after we really thought through these challenges in detail during design. And we had quite a bit of fun along the way. This was the day that the mass timber got brought on site in early April. And so here's the 3 of us, and then the building owner who was also a great partner. And with that, I'll hand it over to Sean.
All right, let's share this. All right. So my name is Sean Fox. I'm a senior project manager with Davis Construction. A little bit about Davis. We are general contractor focused solely in the DC metro market. Actually, we very recently spread ourselves out a little bit to Philadelphia. We do about $1 billion worth of construction work in the DC market every year. So we like to think we touch just about all types of projects, but I specifically work in a group that specializes in repositionings and reuse of existing structures. So being able to reduce the embodied carbon in a structure by reusing it is what we really specialize in, and we really like reusing all these old buildings. So to follow up with what Lauren was saying about our partners, I can't say enough good things about the team that we had to put this project together. And a lot of this goes to our owner, Columbia Property Trust, and that's Jesse Stevens and Anthony Vieira, for helping to put this together and making this dream become a reality, willing to take a risk on a new construction type and really being the first, not only just in the DC market to do something like this, but this is the first overbuild in the United States that we're aware of. And the size and scope of it are definitely challenging. And to do this on top of an existing building that has 6 full floors of occupied tenants is always fun. So they've been a phenomenal partner for this one. And then Hickok Cole and Arup both for having the foresight to be tackling these challenges years and years in advance and bringing to the table knowledge and experience and not having to figure all of this out when we started this job up. And unfortunately, I do have to say, with a little bit of regret, Katerra was a great partner on this job. Unfortunately, they don't exist anymore, but many of the relationships that we made and partners are still propagating throughout the timber industry, and we still see a lot of these folks on future projects. So they were a great partner. Unfortunately, they were just unable to sustain their business model. So Jason hit on a lot of the schedule, but this is very, very broad. We started this back in 2018, and that was when Columbia approached Davis to talk about how to reposition the building. And we get this a lot. Most people assume that our owners are reaching out to design folks early, but the reality is a lot of them will come to us directly, because the most important part of making these things real is the cost associated with it. And we generally have the greatest handle of where these things go and what we've seen in the market. But about a month after this, we brought Jason into the mix, and Jason brought Arup into it as well. So we had a full team years before this project took off. And that really helped with the multiple iterations of, is it 2 stories? Is it 3 stories? Is it concrete? Is it steel? Occupied penthouse? No occupied penthouse? And then, we get this curveball thrown at everybody a few months into it. Hey, what about timber? And so it allows the team to adapt and to provide a lot more options with a lot more accuracy. So having all partners on board as early as possible, this really was a key to delivering this project. But we started the job in earnest in April of 2020, and we are scheduled to deliver. The base building is wrapping up right now, any day. And then we have some add-on lobby work that's going on. So right at a 22-month construction schedule. And that may feel a little long for any general contractors or other owners or design professionals out there, but we did have some added challenges with elevators and sequencing and the occupied building. So the first, call it 6 to 7 months of the job, was nothing but modernizing some elevators to get ready for the overbuild. And I'll show you guys what that looks like in a second. But from the release process and timeline, so we had, our conceptual budgetings for timber and steel. And what we eventually found out was we went into this with the assumption that the timber was going to come at a cost premium, and we were budgeting anywhere between 10 and 20% over the cost of a steel structure back then. And that's kind of holding true right now, although lumber prices are on their way back up, and there's some other challenges there. But we're generally seeing about 10% over for the cost of an equivalent steel structure right now. The lucky thing about this job is when it released, Katerra had just opened their factory in Spokane, and really got the job, really was hungry for work, wanted to load up their factory and get work on the books. And they came in right around the cost of the steel package. So the owner really saved quite a bit on the back end of this. They had assumed it was probably a 1% addition to the job as a whole. And the reality was this one came in right on the original steel budgeting targets. I don't think that's going to be real moving forward. It really depends on the commodities markets. The mass timber installations are generally about 80% material cost, which is quite a bit drastic. It's hugely material driven, whereas steel and concrete tend to be, steel is typically about 40% material, and concrete can sometimes be even less than that. So it's very susceptible to the commodities market. But once we had chosen timber, and Hickok Cole had, and Arup, a very Herculean effort to get that through permitting and approved, and I think it was like 11 or 12-month time frame, we were able to release the job in January of 20, and we started in earnest in April of 20. We kicked off the job in January with this fourth bullet point, delegated design. And it was more design assist for what we'd end up with. Arup had a complete design for the job, and Katerra filled in the gaps and created the connection details. And the connection details were unique in the fact that they didn't exist. So I won't go too much into that because Jason already talked about it. But the submittal process, so from the day we released Katerra to getting timber, to getting submittals approved, was about 10 months. And that is quite a bit longer than steel. That's quite a bit long. That's definitely way longer than concrete. So something to think about as you're looking at jobs, or you're looking at construction projects, or you're looking at utilizing mass timber in any way, to note that there is quite a bit of extra time necessary to get mass timber onto your site. Right now, I can typically get a 100,000 square foot building or addition in steel in anywhere between 4 and 6 months, submittals included. And then right now, timber is taking 12 to 14 months for some of the larger fabricators. A lot of that has to do with demand. There are ways to get it back down into that 10-month range, but it typically involves utilizing multiple manufacturers and different systems and different vendors all across the US and Canada to piece that together. But it takes a lot more pre-planning. You can't just release the job and expect to have your structure in a couple months. So through the design assist process, we were talking about a lot of different things of how we were going to approach testing and how we're going to approach connection designs and profiles and sizes. And so what we did in that 10-month time frame to get submittals all the way through is we used about 3 months of that time to optimize the structure. So Arup designed the structure, and then Katerra came in and using some of their proprietary sizes for different materials through the glue lam or through the CLT was able to eke out about 3 or 4% out of the overall mass of the structure and really the cost by going to sizes that they needed. So because we had the time, we were able to do that. And then we used about 3 more months of that time to do the fire testing, which you've seen a bunch of images of. So if you have the time, there's a lot of opportunities to create value in that process. And then the shop drawing and final shop drawing process isn't very different from taking a look at like steel shop drawings or trying to get steel fabrication processes. But there are new things that a lot of people see, and it takes some time. So just plan for those. So that's really the schedule right there. Right? We released them in 2020, and then we had fully approved shop drawings at the end of November. And then we started production in early 2020, and then we delivered timber on site in March. So overall, about a 14-month total process getting materials on site, but a lot of that had to do with that we didn't need it. We had the foresight to release timber early. We had the foresight to try to get through all the design challenges as quickly as possible, and it led to a very successful procurement of mass timber, and it being delivered on the day we planned for it over 1.5 years prior. Sorry, 13 overall months. Talking a little bit about the materials. So 2 very different fabrication processes here and 2 different manufacturers were utilized for the job. Katerra was in charge of the entire structure, but they sourced their materials both in-house and from a company called Nordic in Montreal. So the glue lam columns and beams were produced using kind of a very old school method. They're manually pressed in a factory in Canada. They take a lot longer, getting the timber beams and the columns here took about 3 months worth of production to get them on site. Whereas the CLT decking, you can see in the photo, only took us 7 non-consecutive days to get on site. So they roll out about 10,000 square feet of this material out of that factory at any given day. We needed, I think it was like 72,000 square feet. So they were producing it as needed, putting on a truck, and this material came from Spokane, and it was arriving to site the night before it was needed and being installed directly off the truck. And I'll show you some photos to kind of show that process because it's very different from what we're normally used to. And then we have a bunch of steel connections in this assembly, which aren't aren't necessary for every job and every mass timber application, but because of our fire connection design and fire detailing, we ended up with a sizable amount of steel that needed to still be procured and used to make these connections. And to show just really what that looked like, Jason had a really good diagram as well, but you can see all the little dark pieces in there. That's all steel that gets hidden inside the timber. So this was a very elegant design that was worked by the entire team, Arup and Katera and Hickok Cole, to hide all of this steel. So when you walk into this building, you see nothing but the expression of the timber. It's absolutely beautiful. Katera and the mass timber process in general is a bit of a change for the general contracting world. It's much faster and it's much more of a prefabrication operation, like a prefab or modular installation than what we're used to with steel or with concrete. So this is just a call it 3-day time lapse of what Katera was planning to do and how much they were planning to install on any given day. And they pre-plan every single delivery to arrive on a certain day. It gets picked directly off the truck and it gets installed, columns, beams, and CLT decking. And they hit this schedule pretty much nose on. They finished up 3 days earlier than they had planned, and they finished up about 2 weeks faster than Davis had planned, because we did not believe them when they told us they could get this done. The timeline for this job was March 2021, and they were done 7.5 weeks later, like April 24th. That is insane. The equivalent steel structure would take at least 12 to 14 weeks with a double the size crew. So when we talk about the speed of mass timber is a huge selling point in the construction world with owners. Time is money, and they're able to get structures up. We're able to get dried in faster. We're able to start tenants faster by doing this. And a lot of it is this pre-planning. A lot of it's the modularity of the structure, the fact that it's all CNC milled together. We deal with far less field corrections and fixes than we would with the steel building, and it's just not as slow as concrete. Concrete is slow. But yeah, 7.5 weeks with a crew size of 7 folks, got a little bit over 70,000 square feet of mass timber installed on the top of an existing building. And again, steel would have been 12 to 14 weeks, crew size would have been double. So to talk broadly about the job, because ADM is unique in that it's not just the timber that makes this job extremely unique. It's a vertical expansion, it's an occupied structure, and there's a lot of other things that go into a job like this. So when we're talking about reusing existing structures, there's a lot of logistics that go into this, including temporary mechanical systems, how you're going to run your elevators, especially if you have overhead traction elevators that are on your roof that you want to use for new space, how you build your new floors. And then we'll get to some photos and kind of show you. So talking really roughly about the sequence of the job, this is the final configuration. You can see the new and old from all the photos. But our first effort on the job was we had 7 columns that we needed to go reinforce to carry some of the load of the new structure, which was pretty minimal. And Arup was able to locate these in areas that were that did not impact tenants greatly. So the 2 ones that go all the way up the building were in a mechanical room and in a stairwell. So minimizing impact to tenants is a huge selling point for your owner. For anybody living in that building during this process. We had to modernize the elevators phase 1. So that was the first 7 months of the job, was just taking out the elevator machine room equipment overhead and changing our elevators over to MRL, so machine roomless elevators, and then putting it back into service so that the building could continue in operation, and then we could go wipe out the penthouse. And then we had an entirely separate mechanical system that was staged down in the alley adjacent to the building, where we ran condensed water up and down the side of the building. We used some of the new equipment in temporary configurations to run the existing building during construction. So this was in place for the better part of a year, actually. It was like 11 months that we were running this entire occupied building off of a temporary mechanical system. Then we removed the existing roof, build that new 8th floor steel deck that Jason had some of the details for. Steel core went up before any of the timber got started. And then we ripped out the existing elevator machine room. We kind of left it in place as long as we physically could, because Elevators are typically some of the most challenging subcontractors on the job, and they have some of the most challenging schedules, and we kind of left it in place to remove them from the critical path. And then there was mass timber, and mass timber was an easy installation, to be perfectly honest. And then we modernized the second bank of elevators, so that was two full banks. So that probably doesn't mean a lot, but we can look at this in photos, right? So this is as we were just starting getting ballast and getting some of the roof up. So October of 2020. A month after this one, you can see we've got that center bay ripped out. And we started in the middle of the existing penthouse, because that's actually where we mounted our tower crane. So it's not atypical, but you don't see it very often in DC. But in urban environments, we run out of a lot of space on the side of the buildings for tower cranes, and we couldn't put one through the building like we would in a new build, so it went on top. A month after that, we've got the entire penthouse down, and you can start to see the little steel stub columns mounted to the roof. These are what's going to carry the new structure, and we're leaving that elevator machine room in operation right now. This allowed us to start earlier and cut a couple months out of the schedule, but you can see tower crane is now up and functional. This is probably the hardest part of the job from a logistics and just timing standpoint. We're installing steel in the middle of winter. The steel is about 44 inches above the deck. You have to climb over it. We have to build temporary walkways. This is the hard part of the job from the construction standpoint. But you can start to see we're going vertical with the core here as we're starting to build out this dunnage layer. A month later after that, we're starting to deck over, get ready for concrete. And then 1 month after that, that steel core is done, and you can see the first delivery of timber is laying on the deck right there. So those are our first columns, and they've been pre-installed with the little steel tube posts on the top of them. They pre-installed as much of the steel as possible, so this thing would go together like an erector set, and it really did. Then these photos start to come a little faster after this. So we're 2 weeks after that point. We've got structure, columns and beams essentially all the way up on our first level. 2 weeks after that, we're 2/3, 3/4 of the way decked out. I'm sorry, this is only a couple days after that. That was 4 days after. 2 weeks after that one, we've got the next structure called 60% up. Another 2 weeks after that, we're basically structure done, waiting on CLT at the top. And this is photos a little bit later. They wrapped up at the end of April, but this is the entire timber structure fully installed. So Katera at this point is gone. They are no longer on site. And then this is a photo from a couple days ago. So we still got a little bit of roofing and balconies, but we're getting ready to wrap up and pull out pretty soon. A couple things that we've learned in this process that everybody should be aware of, but water mitigation is really one of the most challenging parts of mass timber use. It's a natural material. It stains pretty easily. It has moisture content requirements. Maintaining that moisture rating, keeping water shedding plans together, making sure that we're not getting pooling water for long periods of time, taking care of staining are all very important. So you can kind of see in the photo, we have that checker flag tape is a product from a company called Rothablas. It's specifically designed for mass timber installations. We seal up all the spline joints in the CLT so that water isn't constantly leaking through them and staining the timber below, because all that below is exposed. You can see the little metal brown piece of flashing. We put flashing and drip legs everywhere. I mean, there's a lot of work that goes into that temporary waterproofing here, just to make sure that honestly that the timber maintains its integrity, but also mainly visually. And we just want it to look good when we're done. And you can kind of see just more of these little drip legs. We don't want water pooling and flowing over the sides of this to create a lot of staining. The construction tolerances is probably a big one from our point of view. So from Davis's, we were very careful how we bought this job, because we have all three really structural components in this, and that we have a steel structure, we have a timber structure, and we have a concrete structure, not even just the topping side, but it's a real concrete structure. But the tolerances in the different materials are vastly different. The timber tolerances are truly 1/8 of an inch or less. You know, these are CNC routed together. They fit tight. They have to fit tight because of their fireproofing requirements. Whereas at the heights we're working at, steel could be upwards of 3/4 of an inch off in the horizontal direction. So as we created the connections where we go from timber to steel, we had to create as much tolerance as we could. And a lot of times it wasn't feasible. So we ended up field installing a lot of conditions to make sure that we met the tolerances required. And then we had some other ideas like temporary storm systems to help drain the building additionally. You know, we're only 3 stories here and we're only exposed for about 4 months to the elements before the roof is at least majority on. Larger structures, you got a lot longer time that you're going to be dealing with the water. So think about, you know, what you do there. You can kind of see here, here's some of the unique connections that were designed as part of this job where we carry multiple connections between timber and steel. You see everything's pre-routed when it comes out. That is it. So I think I'm wrapping up here. So I think we're going into questions, right?
Yeah, that's right. Thank you so much for that wonderful overview of the project. A lot of great information. I'm especially interested to hear more about the project timeline. I don't know if you have any kind of feedback on overall how fast it went up was really amazing. I don't know if you have any extra information to share along that line.
Yeah, from a schedule perspective, we planned the job. It was a 22-month job, and it stayed a 22-month job throughout the entire process. The steel took about twice as long for half the square footage to get in. As soon as the last photo you saw went in with of the timber structure, we probably spent the next 3.5 months till call it like late August, putting concrete on top of the decks and then getting the curtain wall in. So that's one of the challenging design aspects for this is typically as soon as the structure would have gone in, we would be hanging curtain wall almost immediately. But we did have this extra layer of concrete structure that to carry the lateral load, so we didn't want to load the building up. So that was kind of a big difference in what our normal sequence of operations would have been. And then through the fall was really getting mechanical systems online and getting us completely dried in. And that big decorative canopy has been one of the big challenges on the job too. Those Y columns that Jason loves are finding somebody to build those. They're rolled and tapered steel tube columns that lean out over the perimeter of the building. And there's only 2 fabricators in the US that can do something like that. And luckily we used a company out of York to do it. And they are absolutely beautiful, but they're very challenging.
That's great. Well, it looks like we have a question in the chat. What was the procurement abnormally slow due to COVID?
No. Honestly, this job, because of how it started right as COVID was starting, but because we had that long lead up, we didn't get any of the major challenges that were associated with that March 2020 to late summer. This first, call it 4 to 6 months. The procurement really isn't abnormally slow at all. Like I wouldn't walk into a timber job expecting to get material any faster than 8 months. If somebody's telling you that, you're you're in for a surprise.
Great. Another question in the chat: with the higher ceiling heights, was an underfloor HVAC and sprinkler system considered?
I'll take that one. We did conceptually look at that, but I think in the marketplace, particularly for high-end trophy class office space, underfloor systems, the access floor systems aren't really a desirable kind of floor finish for this type of environment. But it was something we did look at initially. We also contemplated radiant heat as well, because we were very conscious about the aesthetic of seeing ductwork and sprinkler piping. But in the end, we chose to go with a VRF system, which has lower profile ductwork and smaller piping, and then also let us use kind of compressors up on the penthouse roof to capture more real estate from a rentable perspective.
Great. It looks like Melanie, you raised your hand. Great. Hi.
Hey, all. I figured I'd turn on my camera for a minute. It's been really fun to see it go up when I'm down in the Navy Yard and just see those columns as well. So I've enjoyed that. I had two quick questions. One for maybe Lauren and Sean about mass timber production in the Southeast and whether that's like come along at all, or if it's still all kind of coming from Canada and the Pacific Northwest. And then has this project sort of changed the way you think about designing and construction, and what are you kind of taking away from it?
Try to take that first. Hi, Melanie. I know, so yeah, maybe Sean, you would know more lately about like CLT production down in Southeast. I know they are trying to open up more plants down there, and then there's one now in Arkansas. But the other thing I've learned recently is like one of the hardest things to procure is glulam. There's like very, very limited glulam suppliers for this size of glulam for this type of building. And I've learned that actually the holdup is that a lot of the glulam producers that you may think of, like Rossborough or Anthony Forrest, those types, they don't have the CNC ability to fabricate for buildings like this. So I know that people are looking into kind of like basically setting up fabrication shops down in the Southeast to help with that and like use the pre-existing glulam supply chain down there, but then fill in the gaps that would be needed for it to be used in, you know, larger scale mass timber buildings. Do you have anything to add to that, Sean?
Yeah, we're definitely getting a lot more pricing coming out of like particularly structure lamb down in the Southeast. So with Katerra collapsing, the CLT market has become a lot tighter. So getting CLT, what used to be relatively simple, especially after Katerra had ramped up their Spokane facility, has become a lot harder. And the glulam is the challenging component, though. There are a lot of small to mid-sized fabricators that are willing to send glulam blanks, but they're not going to send them to us, or they're not going to send to prefabricated. So the largest one in Canada right now is Nordic, and you know, jobs that we're budgeting with these guys who will do both the glulam and the CLT are taking 12 and 14 and 16 months. A lot of that's demand driven. It's not that they're slow; it's going to take that long to book the job. But we are exploring lots of opportunities across the market to combine a lot of different fabricators and secondary fabrication ideas, especially when our owner schedules demand it. But that does come at a significant cost premium.
And then Melanie, I think to your second question, I also wanted to highlight, so the more that I've sat with this project, the more I appreciate it as like a building type that we should be doing more of. And the new 2024 IBC, the type 4B construction that Jason pointed out, will allow for exposed CLT, full mass timber, whereas before it used to be covered. So basically the code change will make an easier pathway for a building like this rather than having to follow what we did.
Great. I think the next question came in through the chat. What is the commercial software available to design, analyze the timber building? ETABS, RAM, or RISA? I'm not familiar with any of them.
Yeah, it's like very specific structural software. We have an internal finite element analysis software that we use, and then just use some spreadsheets because, yeah, the software that this person's pointing out doesn't have timber design built in at the moment.
Great. And then there's another raised hand from Sean.
Hi there, thanks. My question was about the topping, and was there any review done of systems without that topping, and are there any feasible alternatives right now to try to get that concrete out of the embodied carbon pie?
Yeah, well, I think, Sean, we've talked about how, like, from a code standpoint now, we can do away with it and use CLT. Jason or Sean, do you guys have thoughts on like what that buildup could be acoustically?
Yeah, maybe we could certainly look at doing it in Gypcrete. You know, a lot of our residential projects are exploring Gypcrete, but it also dovetails into the vibration analysis that Lauren was talking about too, because the concrete, right, adds some mass, which adds some dampening, right, to the, particularly in this project with the longer slabs. But it is something that I think we've all taken away from on this project, that if you didn't need to do it structurally, it would be good to avoid it, because it was also, it's basically introducing a bunch of water on top of the CLT and glulam, which, you know, you're trying not to do. So using a product like Gypcrete might be more viable. Then I also think, as Sean was talking about, from a construction sequencing, you know, we were done with the timber, but we had to pour all the concrete before we could put the curtain wall on, because we had to load the slabs, and that left us, you know, quite a bit of duration where the building was exposed, where if you could use a lighter weight topping like Gypcrete and potentially, you know, pour it after you've set up the skin, then you'd be weather tight faster.
Yeah, a lot of our West Coast friends tell us that's typically how they're tackling. They're using the CLT to transfer lateral loads, and then drying their building in 100% before they do Gypcrete or whatever topping that they're using for the project.
Great. Oh, looks like one more question came in the chat. Which strategies were the most useful to help with the DCBC provision changes? I think really kind of understanding the code and the intent of the code. You know, DC is, as I said, was very, you know, very progressive on the sustainability side, and through DOE and DCRA, they're very interested in doing this sustainable type of construction. Where we lack as a whole, code development is very slow in the district. So I think DCRA is certainly open to this type of construction, but not fitting neatly into 4A, B, or C. We had to come up with a hybrid approach and just really explain how it was an equivalent and how life safety was addressed. And so I don't think, I think just understanding the nuances of the code and the intent so that you could develop a strategy specific for this project was probably the most critical part. Sounds like the communication pathway was really helpful there as well. So that's really great. Yeah. Great. Are there any other questions? Okay. Well, we appreciate your time and this great presentation, and look forward to the next event on March 4th, where we will have a coffee break to kind of go over this discussion as well as any other networking opportunities. So we appreciate everybody's time, and have a good weekend. Thanks.
Thanks, everyone.
Thank you, everybody.